In 4.3, we're going to talk about quadratic functions. Section 4.3 is about quadratic functions. Specifically, we want to learn about quadratic functions, their graphs, and then we want to learn maximization and minimization problems. We want to learn about that, okay? So let's start out with a definition. A quadratic function. A quadratic function f in the variable x, meaning x is a variable, also known as a what degree? Very good, second degree. First degree is what kind of function? A linear function, very good. Quadratic is a second degree polynomial function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. What formula did you learn where you had to have a quadratic function? What formula? What formula did you learn that requires you to have a quadratic function? Talk loud. Negative b plus or minus the square root of? Say it again. Not 4 minus AC. B squared minus 4AC all over. So let's put it all together again. You learn negative b plus or minus the square root of? B squared minus 4AC all over? 2A, very good. What formula was that? Quadratic formula, very good. So you had to have your equation in standard form, which was ax squared plus bx plus c equals 0 to identify a, b, and c, right? So in this section, what we're really doing is we're learning about quadratic functions and what the shapes of their graphs are, okay? And we're going to talk about maximizing and minimizing problems. So a fact, the graph of any quadratic function is a roughly U-shaped curve known as a, very good, a parabola. As a parabola. Okay? So f of x equals x squared. How many of you are familiar with Desmos? Raise your hand. Okay? Yeah, there's an app. You can go to it online, www.desmos.com. It's good for graphing. It's good for checking yourself with graphs. So I'm going to graph f of x equals x squared. That is a parabola centered at the origin. What is this point called? Do you know what this point is called on your parabola? I can't hear you.
I said undefined, but that's not the point.
No, that's not undefined. It's the actual point. Can't hear you. Yes, this is the origin. That's the origin, 0, 0. For any parabola, do you know what that point in the middle is called? We'll define it formally soon. I was just wondering if you knew what it was already. Very good. It's your vertex. So when you have a parabola, this point there is called your vertex. You may have an upside down parabola. That point is called your vertex. Okay? So what I want you to do, go to desmos.com. Go ahead. You can use your phones. You can use your whatever device you have right now. Go to desmos.com. And I want you to graph B. And in graphing B, I want you to describe what happened to the graph of A in part B. Tell me what happened. So if you had x squared, did it move up, down, to the right, to the left? How many does it move?
So we graph B.
I want you to graph B. And knowing what this graph is going to be, tell me what happened to A. Does that make sense? Okay, everyone understand the instructions? 2 minutes. What's the graph of x minus 6 quantity squared? It's 0, you said? I can't hear you. What? I can't hear you. Y'all talking mad low. I don't know what's going on. If we were outside and I had $100 and I'm saying, hey, come get this, you gonna talk that low?
X is 6.
Oh, x is 6? What do you mean by x is 6? Oh, the vertex is at 6. That's a better description. Yes? 2, 3, 4, 5, 6. The vertex is here?
Yes.
What point is this? 6 comma what? 0. Very good. And so then we have our parabola. Excellent. Very good. What happened to the graph of x squared? It moved over 6 to the right, right? So this moves x squared 6 to 6 units. To the right. So notice that whenever you have x minus a number on the inside of something squared, the x minus 6 does the opposite of what you would think. It moves it to the right 6. So if we have x plus 6 squared, where is it going to go? To the left, how many? 6. Very good. So if you have x plus 6 quantity squared, the graph of x squared is going to move 6 to the left. Okay.
So would this be like with anything as far as having an exponent like 2 or even like, I don't know if we're going to use cubic at all.
You will. This is only happening with x squared. The shape of x squared is this parabola.
So we'll only turn it into a positive.
What's your it?
If it's square.
If it, what is it?
6. Negative 6. Well, like how you said.
X minus 6?
Yeah, x minus 6. Like,
X minus 6 quantity squared has this graph.
like you said, it does the opposite. Is that
X plus 6 quantity squared. The x plus 6 means you move 6 units to the left.
Oh,
Yes.
You just make it squared. Does it only move?
If your, what's your it? Is it, you gotta be specific. Is it your function? Use your words. If your function is squared, go ahead.
If the function is squared, that's the only number that does the opposite.
No. That, okay, so I understand your question now. If your function has, your exponent can change. So let me say this. Your exponent can change. We can do x minus 6 quantity cubed. You can do x plus 6 quantity cubed. Since you're asking me this question, let's go ahead and answer it now, okay? So if you have, and I would typically reserve this. This is going to happen in section 4.4. This is going to happen in section 4.4. What your question is really going into is section 4.4, but I want to ask it right now, or answer it right now, so you can see what's going to happen. So I'm not going to write section 4.4. I'm just going to say, if you have f of x equals x cubed, we're no longer talking about quadratic functions, right? Excuse me, f of x is equal to x cubed. Is there a question in the back? Is there a question? Okay, so you have your xy plane. If you graph x cubed looks like this. Go ahead and take a minute and graph it in Desmos. Go to desmos.com. Go ahead and graph f of x equals x cubed. And now to answer your question, we're going to use the same thing, but we're going to have the exponent as cubed. Tell me what is the graph of, let's call it g of x. What's the graph of g of x equals the quantity x minus 6 cubed? And what is the graph of k of x equals the quantity x plus 6 cubed? What do you think is going to happen to the graph of the quantity x minus 6 cubed? What do you think is going to happen? It's going to move what to the right? What's function?
Function x, g of x, x minus 6 cubed.
It's not moving g of x equals x minus 6 cubed. It's moving what function? It's moving x cubed, right? X minus 6 quantity cubed is going to move f of x equals x cubed. How many to the right? 6. Confirm. Confirm it in Desmos.
It's like
Say what? It's like a pattern, right? That's what's happening. That's what's happening. It looks the same as x cubed, right? It's just moved to the right. How many? 6 or 3? I heard 3. 6? Which one? 6?
Oh yeah,
It's 6, right? That's that minus 6 on the inside. For x plus 6 quantity cubed, what happens to the graph of x cubed? It moves it to the left 6. So see, that still happens. So the minus on the inside of a function that you already know the basic graph of, it moved that x minus whatever that number is, moves your original function to the right that number of units. If you have x plus that number raised to that power of your basic function, it moves your function, your original function, to the left that number of times, that number of units. Does that make sense?
yeah.
Okay. So all of these things you're going to see in section 4.4, but it's good that you're making the connection now. Okay? All right. So back to quadratic functions. So a definition, the vertex form of a quadratic function, the graph of the function g of x equals a times the quantity x minus h squared plus k, where a, h, and k are real numbers and a is not 0, is a parabola whose vertex is h, comma, k. So notice, this function is the vertex form of a quadratic function. Excuse me. It's the vertex form of a quadratic function. Notice that you have to have x minus h quantity squared to get h as your vertex, as the x coordinate of your vertex, plus k. K is the y coordinate of your vertex. So a few facts. If the absolute value of a is greater than 1, then the parabola is narrower. If the absolute value of a is greater than 1, then the parabola is narrower than f of x equals x squared. So if the absolute value of a is greater than 1, so if you have this number here and you take the absolute value of it, it's greater than 1. So you may have 2, 2.5, 3, 4, and so on. If a is greater than 1, the absolute value of that is greater than 1, then the parabola is narrower or skinnier than f of x equals x squared. So in other words, what happens to your parabola, excuse me, what happens to your parabola is that it stretches it. It stretches the parabola. Okay? If the absolute value of A is greater than 0, but less than 1, so if you have the absolute value of A is any number between 0 and 1, not equal to 0 and not equal to 1, but positive, then the parabola is broader than f of x equals x squared. So in other words, it widens it. Widens the parabola. So shaped like this. So it makes the parabola wider, or it compresses the parabola. Okay? If A is greater than 0, then the parabola opens upward. So if A is positive, the parabola opens up. If A is negative, the parabola opens down. So you have an upward facing, downward facing. Okay? What questions do you have? You need a second here? Yes? Okay. So, example 2. Example 2. Graph the following quadratic functions. Locate the vertex and x-intercept, or septs, if any. Here we have g of x equals negative 1. That's a negative 1 on the outside. If you need to write 1 there, feel free to do so. But you're going to have to understand that this is a negative 1. G of x equals negative 1 times the quantity x plus 2 squared minus 1. What's your vertex? Negative 2, negative 1. Very good. Where did negative 2 come from? You said distribute? Distribute what? Say what? Can you distribute this negative on the inside of this? Do you all have questions in the back? Can you distribute this negative? What's preventing you from distributing that negative? The squared. If you're the exponent, if this exponent is not 1, you cannot distribute a number in front. You would have to expand first, then distribute. But because it's in this form, we cannot distribute this negative on the inside. We cannot. So where's the negative 2 coming from? Can't hear you. Say what? Flipping the signs of what? The 2? So you notice here, your form says A times the quantity x minus h squared plus k. So here, this is a plus, which means you're subtracting a what? This is the same thing as negative times x minus what? X minus what? No, in terms of what I gave you. If you have negative times the quantity x plus 2 squared minus 1, that's the same thing as the quantity x minus what quantity squared? If you put a 2 here, is that the same thing as this? I can't hear you. No, you're guessing. No, I'm asking. This, what we're writing here, has to be the same exact thing as this. But if you're subtracting, what does this number have to be? If we have x plus 2 here, this has to be x minus what? Say what? I heard 3 different things. If we want this to be equivalent to x plus 2, this has to be x minus what? Negative 2. Has to be x minus negative 2 quantity squared. So when I asked where did the negative 2 come from, it came from right here.
Because of the formula.
Say what? Because we put our original equation in this form, in that form that was given to us. So yes, with that formula. Does that make sense? A little bit? You want me to explain it again? Okay. So here we have, so the vertex form of a quadratic function is this blue highlighted form. G of x equals a times the quantity x minus h, quantity squared, plus k. Our function is given to us in this vertex form of a quadratic function. It's given to us in this form. The only difference is here we have x minus h, here we have x plus 2. So if we rewrite the x plus 2 as x minus negative 2, then our g of x here appears in this same form, vertex form. So now our h is this negative 2. So that's where that negative 2 came from. And the minus 1 came from here. Questions? Yes?
Let's say we gotta put it.
Let's say what?
Let's say we still have to put it, let's say the first part was x minus 2 squared.
Yes.
Still need to put it in that same form.
No. If you have negative times x minus 2 quantity squared minus 1, is that what you're saying? Then what would your vertex be? Positive 2, negative 1. Yes. Questions? Okay. So we identified our vertex. What else do we have to identify? Our x-intercept. How do we find our x-intercept? We said what equal to 0? Y. Very good. So we have, so that was something different. So,
I have a question.
yes.
How did you come about?
Say what?
How did you come about?
I can't hear you.
What made it positive 2?
Oh, for the green? That was a different question. So if you have x minus 2, if you have negative times x minus 2 quantity squared minus 1, your vertex is hk. So if you look back up at your vertex form of a quadratic function, you have x minus whatever number squared. Here, your vertex is hk. Your vertex is hk for this. So the vertex here, because it's x minus, we just pick up the positive of that. What other questions do you have? Okay, so back to part A, whenever we have to find our x-intercepts, we know that our vertex is negative 2, negative 1. So let's ask ourselves, you said to find our x-intercepts, we set y equal to 0. What do we know about this parabola because this negative is out front? It faces downward. So if we go to negative 2, negative 1, this is our vertex. We know our parabola faces which way? Down. So will this parabola have any x-intercepts? No, it will not. So no x-intercepts. Okay? All right. So that's part A. Let's look at another one. Part B. I see some still writing. Part B. Part B, we have f of x equals x squared plus 2x plus 4. Now, most of the time you will not have to use, in this particular problem, we haven't gone over another way of identifying what your vertex is, what your x-intercepts are. And at this point, what I want to do is go over what's called the vertex formula and tell you how to do that. Because what I was about to show you, I will go ahead and show you with this one, but you will not have to do this process with every one. Remember completing the square that we talked about? Do you remember that? That was a question. I heard one yes.
Yes.
Completing the square. So if we had to complete the square, we take the coefficient of what? The process. I'm asking the process. If we have to complete the square here for x, in x, what do we do? Take the middle term. So we take the coefficient of the middle term. Very good. We would take the coefficient of x, which is 2, divide it by 2, then square it, add that to both sides. So very good. So let's complete the square in x here. So here, I'm going to show you how to complete the square and stuff here. In the next example, before we do it, I want to explain to you how to use the vertex formula, which is further in this note packet. So for this, we want to make sure we put this function in our vertex form of a quadratic. We want to put it in this form because we know the vertex is h comma k. So here, for f of x equals x squared plus 2x plus 4, we have x squared plus 2x. We're going to leave some space. We're going to add 4. Did we change the equation? Did we change the equation?
Yes.
Yes, how so? It's different from the first line? Is the equation in line 2 different from line 1? Yes, how so? It has parentheses, and the 4 is on the outside of the parentheses, but is the function the same?
Yes.
Yes, so did we change it? No, we did not change the function. We just added parentheses, because what we're getting ready to do, we're going to put a number in a certain way. We're going to complete the square. So, what we're going to do in this step, we're going to complete the square on the x squared and 2x terms. Which means we take the coefficient of x, which is 2. We divide 2 by what? Divide 2 by 2. That's equal to what? 1. Then we're going to take 1 and do what? Square it. That's equal to what? 1. So here we have x squared plus 2x plus 1 plus 4. And technically, on the left, you will put, since we put a 1 here, you will put a 1 on the left, right? Are you with me?
Yes.
So I'm going to put this f of x plus 1 here. So what we did here, we also added here. So that way, we really didn't change the equation. So now I'm going to subtract 1 from both sides, because I want f of x to be by itself on the left. So this is f of x equals the quantity x squared plus 2x plus 1 plus 4 minus 1. We subtracted 1 from both sides. Okay? 4 minus 1 is 3. This quantity, since we've completed the square, we know we can write this as x plus 1 quantity squared. All of that plus what? 3. Same equation. Same equation as this, written in a different way. We completed the square. The benefit of writing it this way is we can identify our vertex. What is our vertex? Say what? I just didn't hear you. Negative 1, 3. Very good. That's your vertex. Negative 1, 3 is your vertex. Now, is this parabola f of x opening up or down? Up. So if you're sketching it, your function f of x, then we know our vertex is negative 1, 3. So negative 1 up 3. We know this is our graph. We can make our parabola a little bit better. So what can we say about our x-intercepts? I can't hear you. There are none? Very good. There are none. No x-intercepts. If this parabola were opening downward, would you have x-intercepts? Yes, you would. And the benefit of then finding your x-intercepts, you can use this standard form and use the quadratic formula to find them. Okay?
Ma'am, so the 2x canceled out. Is that what happened?
Say what?
The 2x.
This 2x?
Yes, ma'am.
No, that didn't cancel out, because if so, you would have x squared plus 1. Remember, when you complete the square, the goal is to write this quantity as a perfect square. So if you expand x plus 1 times x plus 1, you get x squared plus 2x plus 1.
Okay, I see. Okay.
Yes. So this quantity, x plus 1 times x plus 1, is x squared plus 2x plus 1. So on the side here, note x plus 1 quantity squared is equal to x squared plus 2x plus 1. What other questions do you have? Okay, so part C, I want us to use the vertex formula. So let me tell you what the vertex formula is. The vertex formula, which is on the next page of your notes if you don't want to write it again, but here I'm going to give it to you. The vertex formula says the following. If you have a given function f of x, a quadratic function ax squared plus bx plus c, then to identify the vertex, your vertex is given by negative b over 2a, comma, f of negative b over 2a. So in other words, you identify your a and b, find negative b over 2a, then take that and plug it into your function, or substitute that x value you get into your function. That will give you a y coordinate. Okay, so C, we have k of x equals 2x squared minus 4x. We're going to use the vertex formula. We're going to identify our vertex. We want to identify our vertex and our x-intercept or intercepts, if they exist. So, what is A? What's A? What is A? 2. Yes, what's B? I heard -4, I heard 4. Which one? -4, good. So then, negative B over 2A is equal to negative times what? -4 over 2 times what? 2. This is equal to positive 4 over what? Which is what? 1. Yes? So that is the x coordinate of our vertex. We know x is 1. How do we find the y coordinate? But we don't have f, we have what?
Wow.
K we have, yes. We have k of x. So what are you finding now? K of what?
Negative b over 2a.
Which is what for us? So we're finding k of what?
Negative 4 over.
Be specific. We found negative b over 2a. We're finding k of what? K of x, our x is what? So we're finding k of what? 1. Yes, we're finding k of 1. K of 1. Because that's our negative b over 2a. We don't reinvent the wheel. We found negative b over 2a. Let's use what we found. So we're finding k of 1. Does that make sense? Okay. K of 1. So now you're substituting in 1 for x here in this yellow highlighted. So we're substituting in 1. So we get 2 times 1 squared minus 4 times what? 1, yes. 1 squared is 1. 1 times 2 is 2. Minus what? 4 gives us what? -2. What's our vertex? 1, -2. Good. And now, to find our x-intercepts, you can do it a couple of ways. You can either factor k of x. You can use the quadratic formula if you like. Which approach do you want to take? Factor. So now we're finding our x-intercepts. To find your x-intercepts, now so we can ask ourselves, do we have x-intercepts? If our vertex is 1, -2, A here is what? Positive, so is our parabola going to open up or down? Up. So are we going to have x-intercepts? Yes or no? How many don't know? You don't know? How can you find out? How can you know? What can you do? Graph what? The point, your vertex, yes? So if you graph your vertex, what quadrant are you in? You're in quadrant 1, 2, 3, or 4 for your vertex. 4? So this is 1, -2? And your parabola opens which way? Up. So do we have x-intercepts? What? Yes. Now this sketch is not completely correct, because once we find our x-intercepts, you're going to see that this is going to move over. This was just to point out that if you know your parabola is opening up, then yes, you're going to pick up x-intercepts. We have to now find out what they are and make adjustments to our graph. Does that make sense?
Yes.
Okay. So x-intercepts. We set y equal to what? 0. Good. Set y equal to 0, but y here is k of x. So we have 0 equals 2x squared. Let me write down a little bit lower. 0 equals 2x squared minus 4x. These two terms on the right have what in common? I can't hear you. A 2x, good. Factor out a 2x. So you have 2x times the quantity. What's left? X minus 2. Good. That product equals 0. And so now that means either 2x is 0 or x minus 2 is 0. If 2x is 0, that means x is what? Where are you getting undefined from? That doesn't mean everything in here is undefined because you talked about undefined somewhere else. You divide both sides by 2. So you get x equals what? 0, yes? What do we do if you have x minus 2 equals 0? You get x equals what? 2, good. So our x-intercepts are the origin, 0, 0, and 2 what? 0, good. So our x-intercepts are 0, 0, and 2, 0, which means we need to adjust our graph, moving this where? To the right, to the origin, yes? So we make our adjustments. Bless you. You're welcome. So then we have our origin, and then we have here is 2, 0. That is the origin, and that's your graph. I can't hear you. What'd you say? What other questions do you have? Okay, so you have several ways you can find your vertex. Okay? Page 4 is just reiterating the vertex formula. Okay? That's all that is. Do you want to see another example? So I don't know what's going on with responses today. Do you want to see another example, or are you good with the vertex formula? Yes, you do? Okay, so let's go over one more. So, given a quadratic function, f of x equals ax squared plus bx plus c, the graph is a parabola with vertex given by this formula. That's what we just discussed on the previous page. So, example 3, we'll do part A. Part B you can do on your own. Part A, it says p of x is equal to negative x squared plus 2x minus 5. Use the vertex formula to find your vertex. Use the vertex formula to find your vertex. What is the approach? What is your approach? Say what now? I can't hear you. If I'm saying use the vertex formula, do you have to do that?
No.
What you're thinking is completing the square. To put your quadratic in the vertex form of a quadratic function. But here, I've said go ahead and use the vertex formula to find the vertex. So now you don't need to complete the square, you need to do what? Find A and B. Find A and B. So what's A? What's A? A is 2?
Negative x squared.
What? What's going on? What's A? A is negative 1, right? So let's make sure we're all looking at the same thing. This is the form your function has to be in for you to identify A and B. P of x is in this form. So you identify A. A is what? A is negative 1. That comes from the coefficient of x squared. What is B? 2. That's the coefficient of x. go ahead and take a minute and a half and find out what's the vertex. So I heard 1, -2 as a possibility for the vertex, and I was asking someone to confirm. You got this too? Anyone get anything else? Did anyone get anything else? You giving me blank looks, and only 2 people responded to me. You got the same thing? I can't hear you. You right in front of me. Say what?
You said for the vertex?
Yes. I'm asking, did anybody get anything else? Okay, so let's check it. So we have A is -1, B is 2. So negative B over 2A is negative times what? Over 2 times what?
2.
So this is -2 over what?
4.
4, which is the same thing as what?
-1 over 2.
-1 over 2? Is that what we have? That's what you're telling me. I'm writing what you all are telling me. A is -1, so this should be -2 over 2 times what? -1, yes. 2 times -1, because A is -1 over, so we get -2 over what? -2. -2 over -2 is 1, yes? So that's our x coordinate. So far, what you proposed for our vertex, the x coordinate is correct. Now we need to substitute 1 into our p of x, where x is equal to 1. So we need to find p of 1. That's equal to negative times 1 squared, a negative is on the outside, plus 2 times 1 minus 5. 1 squared is, times this negative is, so we get -1 plus what? Minus, -1 plus 2 is? 1 minus 5 is? -4. So, is our vertex 1, -2? Say what? That's correct. So this should be, to correct this, we would have our vertex is 1, -4. So our vertex is 1, -4. So be careful that that negative on the outside stayed with that. Okay? Because that is probably where you got a -2 from. Okay? Questions? Okay, so you can do part B on your own. Okay, you can do part B on your own. Maximization and minimization problems. So whenever you have a parabola facing down, your vertex is going to be a what? Negative? Say what? If we're talking about maximization and minimization, is this going to be a max or min? A max, because it's the highest point. So this is a maximum. So our vertex would be a maximum. If our parabola is facing which way? If our parabola is facing down, our vertex is a? Okay, there's a lot happening. I want to make sure everybody is listening and paying attention. If our parabola is facing down, our vertex is a? If our parabola is facing up, our vertex is a? Minimum, yes? Are you with me? Okay. So, now, It's not going to be very confusing whenever you have to find your maximum or your minimum, because you know that it's implied your function is going to be what type of function? Is it linear? Is it quadratic? So your function is going to be what? In order for you to find a maximum or minimum, what type of function are you going to have? Is it going to be a line? It's going to be a quadratic. In order for you to find a maximum or a minimum, you're going to have a quadratic function. What can you use to help you find the maximum or the minimum of your quadratic function? The vertex formula. You got it. You got it. So now we know automatically what our approach is going to be, right? We're going to have to identify what our quadratic function is. Once we identify our quadratic function, we are going to use our vertex formula to help us find our maximum or our minimum. Okay? All right. So, among all rectangles that have a perimeter of 20, find the dimensions of the one whose area is the largest. So if we have a rectangle, among all rectangles whose perimeter is 20. So we have a rectangle, you have your length, you have your width. So we know that 2L plus 2W, if you add all the sides, 2L plus 2W, that's going to equal what? 20, because we know that's our perimeter. Very good. So these two on the left have 2 in common. That leaves us with L plus W in parentheses equals 20. Divide both sides by 2. That gives us L plus W equals what? 10. Very good. So now we're going to solve for L. You'll see why in a second. So L is going to be 10 minus W. Okay? So we have L is 10 minus W. And now we know we want to find the dimensions of the one whose area is the largest. Area of a rectangle is length times width. Area is equal to length times width. We know L is what? 10 minus W. So L is 10 minus W times W. We know L here is 10 minus W. So we use what we knew about the perimeter, and we substituted this into our area for L. The benefit of doing that was getting our area to be a function of W. Distribute this W because we're multiplying. So we get 10W minus W squared. Rearranging this is negative W squared plus 10W. We have what kind of function? Quadratic function. So now we want to identify, can you tell me, are we going to get a maximum or a minimum? How do you know? It's going down, right? How do you know this parabola is facing down? Because this negative here tells us we have a parabola facing down. We have a parabola facing down, so we know we're going to pick up a maximum. We know that. We know we're going to find a max. So now the question is where, right? Because our goal says find the dimensions of the one whose area is the largest. So we know if we have our x coordinate, which here is W, we know A is what? -1, B is 10. Very good. So W is the x coordinate, and is given by -B over 2A, which is -10 over 2 times -1. That's -10 over -2, which is 5. So that means W is equal to 5. Good. So W is equal to 5. Now, let's call this line up here smiley face. Now, using smiley face, L is equal to 10 minus W. W is what?
5.
So 10 minus 5, that is what? 5. So to answer our question that said find the dimensions of the one whose area is the largest, we know both that the width and the length is what? 5. That's it. That's it. And so the last example is going to show you how to optimize cost. Okay, we're going to how to figure out how to find the minimum cost. I'll record that example. I'll post this video and 4.2. 4.4, we've already talked about some of that. I will go ahead and post a video for 4.4 as well. We'll do a quick review of 4.4 at the beginning of class on Thursday. You'll have your group work activity. Okay, and we'll continue to cover information.
You're selecting the groups first?
Yes, I'll select the groups. I'll see if you all want to select them next time. I may be flexible in that. All right, have a good one. Now, example 5 says the total cost of producing a type of small car is given by C of x equals 9,000 minus 135x plus 0.045x squared, where x is the number of cars produced. How many cars should be produced to incur the minimum cost? So let's first understand why it makes sense that we should get a minimum cost. If we examine our given function, which we see as a quadratic, notice that the coefficient is positive, which means the shape of this parabola is upward facing. So it makes sense that we should have a minimum. Now, the minimum is given by our vertex. We want to find out how many cars should be produced to incur the minimum cost. And it says x is the number of cars produced. So that means we need to find the x coordinate of our vertex. Remember from the vertex formula that negative b over 2a is equal to our x. Okay, that's from the vertex formula. Now, a, remember, is the coefficient of x squared. So a is equal to 0.045. B is equal to the coefficient of x, so that's negative 135. And then we can say x is equal to negative times negative 135 all over 2 times a, which is 0.045. And so that's equal to a positive 135. 2 times 0.045 is 0.09. And then you divide that, we get 1,500 cars. So 1,500 cars should be produced to incur the minimum cost. Okay, do your homework. Have a good one.